Good morning, students. Chapter 3, Motion in a Straight Line. Continue. Today we will see one important theory of this chapter. Yes, theory is important as well as equations we will obtain. They are also important. In mechanics, we have to use these equations to solve some equations, some MCQs, some questions and some theories. Okay, so remember this theory is important. What is title? Kinematic equations for uniformly accelerated motion. First point to remember. This theory, these equations are for uniformly accelerated motion, means acceleration is constant. Acceleration is constant. So whenever in any case you are given acceleration constant, you can use these equations. See, we are assuming situation. Let at time t is equal to 0. Position of object is x0 and its velocity is v0. Okay, at time t is equal to t, position is x and velocity is v. You have to remember this each and every term. Again, position at time t is equal to 0 is x0. It is called initial position. Velocity is v0. It is called initial velocity. At time t is equal to t, position is x, it is called final position and velocity is v, final velocity. So whatever you are given at time t is equal to 0, it is initial, and for another time we can say final. So initial position, initial velocity, final position, final velocity. Okay, now we have to obtain equations. First equation is very simple to derive. Okay, see, for uniform accelerated motion, we know that average acceleration is equal to instantaneous acceleration. For uniformly accelerated motion, average acceleration is equal to instantaneous acceleration. So if I use equation of acceleration, A is equal to delta V upon delta T. Delta V change in velocity. So A is equal to final velocity minus initial velocity. Clear? Final velocity minus initial velocity upon time interval t minus 0. Clear? Now if I multiply this t on this side, then I will get at is equal to v minus v0. And now if I make this v as a subject, you take this v0 on opposite side, okay? Then you will get v is equal to v0 plus at. v is equal to v0 plus at. First equation of uniformly accelerated motion. What is v? Final velocity or velocity at time t. v0 initial velocity and a is constant uniform acceleration. Clear? So how to derive this first equation? It is simple. Second equation. How to derive second equation? See, first of all we will draw VT graph for this motion. See, it is time axis, it is velocity axis. We know that at time t is equal to 0, velocity is v0. At time t is equal to 0, velocity is v0. And at time t is equal to t, velocity is v. So it is point. Okay, so it is initial position, it is initial point and it is final point. And if as it is uniformly accelerated motion, for uniform accelerated motion, VT graph is a straight line. For uniform accelerated motion, VT graph is a straight line. Again, how to draw graph? See, at time t is equal to 0, velocity is v0. At time t is equal to 0, velocity is v0. At time t is equal to t, velocity is v. So this point A initial and B final. Uniform accelerated motion means VT graph is a straight line. So it is VT graph. Okay. Now in a last lecture, in a last point, okay, we made a note. Okay, displacement in any time is equal equal to area under VT curve. Area under VT curve. See, it is VT curve. Then what is area under VT curve? See, this whole area, it is area under VT curve. It is area under VT curve. Okay, area made by this VT curve with time axis. So if you find this area, it is equal to displacement. Then how to write? See, displacement in time t, 0 to t, 0 to t. Displacement in time t is equal to area under VT curve, this part. Okay, area of this curve. Okay. Now, displacement. What is displacement? Displacement means final position minus initial position. Final position is x, initial position is x0. So I can write displacement in time t is equal to x minus x0. Now, how to find area under this VT curve? See, you can easily observe that we can divide this whole area in two parts like this. Okay, first it is triangle ABC and second it is rectangle OACD. Okay, then see, displacement in time t, x minus x0 is equal to area of triangle ABC, this one, and area of square OACD. Okay, what is area enclosed by this VT graph? This one. Now, displacement as it is. Area of triangle, you know what is the equation of area of triangle? It is half base into altitude, height. Okay, see, this triangle, half. Base, this AC is base. And see, this AC is equal to this OD. And this OD is nothing but this T. So this T, base is T. Okay. Now how to find this height? See, here, point A, at this point velocity is V0. Means it is V0. At this point velocity is V, means it is V. Then what is, if OA is equal to V0, OV is equal to it is V, then what is this CV? V minus V0. It will be V minus V0. Okay, then this height VC is equal to V minus V0. Okay, so area of triangle ABC is equal to half. It is base T and height is V minus V0. Plus, what is area of this rectangle? See, this side is V0 and this side is T. Again, this side V0 and this side is T. So it is V0 T. Now, you have to put this value of V minus V0 from this equation. See, equation number 1. From this equation number 1, V minus V0 is equal to 80. V minus V0 is equal to 80. Put here. V minus V0 is equal to 80. So x minus x0 is equal to this V0t plus t into t, this t square, half 80 square. It is half 80 square. So it is second equation. X minus x0 means displacement is equal to V0t plus half 80 square. Displacement, V0 initial velocity, A acceleration, and T is time. Clear? Now, third equation. See, we know what is definition of average velocity. Average velocity is equal to displacement upon time. So, displacement is equal to average velocity into time. Displacement, we know, final position minus initial position is equal to average velocity V bar and time is equal to T. Okay, now x minus x0 as it is average velocity. Hello, for uniform accelerated motion you can also find average velocity as v plus v0 by 2, initial velocity plus final velocity divided by 2. Hello students, you already know how to find average. Okay, if I say how to find average of 5, 10, 15, then yes, you will 5 plus 10 plus 15 divided by 3. So it is matter to find average. So similarly here, how to find average? It is final velocity plus initial velocity divided by 2. Now we have to put value of t. How? We know that A is equal to V minus V0 upon t. Yes or no? Now if you make this t as subject, okay, then they are replaced. Okay, we can write t is equal to v minus v0 upon a. So put value of t, v minus v0 upon a. Clear this step. V bar, v plus v0 by 2, t, v v minus v0 by a. X minus x0 as it is, you know one relation, a plus b into a minus b is equal to a square minus b square. Here it is v plus v0, v minus v0, so you can write v square minus v0 square, and in denominator it is 2a. Now if you take denominator this side, it is 2ax minus x0 is equal to v square minus v0 square, and it is your equation number 3. Clear? So you have to remember these 3 equations. These 3 equations are general equations for any case. If we are taking one case, a special case, if at time t is equal to 0, means at initial time, object is at origin. Object is at origin means x0 is equal to 0. So what are equations? First equation as it is, v is equal to v0 plus at. Second equation, put x0 is equal to 0. You will get x is equal to v0t plus half at square. Third equation, 2ax is equal to v square minus v0 square. You have to remember these 3 equations. Clear? Pause your video and write down from bottom. Now see students, to clear some concept, we will see some extra questions. Okay, so you can also prepare for your competitive exams. Okay, yes, these questions are not in syllabus, but you must know how to find such questions, how to solve such questions. See, vehicle travels different distances with different speeds in the same direction. Find expression for average speed. Find expression for average speed. See, for example, this distance t1 is travelled or covered with speed v1. This distance t2 is travelled with speed v2. Distance t3 with speed v4, d4 with v4. And time taken for such travelling are respectively t1, t2, t3 and t4. Simple. Means to travel this distance t1 with speed v1, time is t1. To travel distance t2 with speed v2, time is t2, etc, etc, etc. Okay, now your question is you have to find average speed. Average speed is equal to total distance upon total time. Average speed v bar is equal to, from figure you can say what is total distance. Yes, d1 plus d2 plus d3 plus d2 plus so on. Okay, because it is so on. Clear? And what is total time? Is t1 plus t2 plus t3 plus t2 plus so on. Now we know that speed is equal to distance upon time. So time is equal to distance upon speed. So if t is equal to d upon v, I can write t1 is equal to d1 upon v1. I can write t2 is equal to d2 upon v2. I can write t3 is equal to d3 upon v3. So if you put value of t1, t2 and t3, you will get this equation. V bar is equal to d1 plus d2 plus d3 plus d2 plus so on, divided by d1 upon v1 plus d2 upon v2 plus d3 upon v3 plus d2 plus so on. So yes, it is your answer. But what is important? Important is special case. See, what is a special case? If vehicle travels two equal distances, d1 is equal to d2 is equal to d with different speeds. It means if it is first distance d, travel with speed v1, and it is also distance d, travel with speed v2, then during this journey, what is its average speed? See, these two distances are equal, so you can write d1 is equal to d2 is equal to d. So in this equation, first of all you have to reduce this equation up to d1 plus d2 upon d1 v1 upon v1 plus d2 upon v2, because you are given only two distances. And now you have to put d1 is equal to d2 is equal to d. Yes, see, if you put its value, what you will get? V bar is equal to d plus d, because you are given only two distances, upon d1 divided by v1 plus d divided by v2. Okay, how to simplify? D plus d is 2d. D and d common. In bracket we have 1 upon v1 plus 1 upon v2. Clear? Okay, now see this d and this d cut, so here only 2. 1 upon v1 plus 1 upon v2. How to simplify this term? You know it is cross multiplication. v2 plus v1 divided by v1 v2. v1 plus v2 divided by v1 v2. This v1 v2 is in denominator of denominator, so you can write it in numerator. So v bar is equal to 2 v1 v2 upon v1 plus v2. If you remember this equation, your solution will become very short. Yes, you have to derive one more special case. Yes, it is tough, but you have to do as your homework. If you are given three equal distances, then what is equation of average speed? Okay, you have to find it. Clear? Now, one more question. Okay. It is based on graph. See, you are given one VT graph. It is VT graph. Okay. Your question is find acceleration at time t is equal to 0.5 second and at time t is equal to 2 second. You may also ask, okay, what is displacement and distance? Displacement and distance we have calculated in last lecture. Now your question is, you have to find acceleration at time t is equal to 0.5 second. See carefully here. 0.5 second, it is time axis. 0 second, 1 second, 2, 3 and 4. So 0.5 second, it is here. It is 0.5 second. And its respective point is here. On this straight line OA. Now if you remember VT graphs, whenever VT graph is a straight line, acceleration is constant. It means if this OA line is a straight line, it means at this point, value of acceleration is same and is equal to slope of line OA. So, acceleration at time t is equal to 0.5 second. A is equal to slope of line OA. Now, how to find slope of line OA? See. Delta V upon delta T, it is just equation. How to find this? See carefully here. A, final position. O, initial position. At this final position, what is velocity? 10. At this initial position, what is velocity? 0. Again, final position, what is velocity? 10. Initial position, what is velocity? 0. So it is 10 minus 0. Okay, divided by delta t. At final position, what is time? 1. Initial position, what is time? 0. 1 minus 0. So it is 10 divided by 1. It is 10 meter per second square. Clear? And this acceleration is uniform, constant for each and every point on line OA. Okay. Now similar question, you have to find acceleration at time t is equal to 2 seconds. See 2. 2 seconds means this point. 2 seconds means this point. And see, it is on a line AC. So now we can say acceleration at time t is equal to 2 seconds. A is equal to slope of AC. A. Now A is the initial point and C is final. Okay. See carefully again how to find slope of line AC. C is final position, velocity minus 10. A is initial position, velocity 10. So it is minus 10 minus 10. Clear? Okay. Time. For C, what is time? 3. For A, what is time? 1. 3 minus 1. It is 3 minus 1. So minus 20 divided by 2, it is minus 10 meter per second square. See in last lecture, okay, if VT graph is in upward direction, acceleration is positive, and if it is in downward direction, acceleration is negative. Clear? So it is how to find acceleration from slope. Okay. Okay. Now we have one we have another question. Y is equal to position minus 2 by 3 t square plus 16t plus 2. How long does it take to come to rest? Now understand question. How long does it take to come to rest? When object comes to rest, its velocity becomes 0. Its velocity becomes 0. Okay, so first of all, from this displacement you have to find velocity. V is equal to minus 2 by 3 as it is. Differentiation of t square is 2t and plus here it is 16 plus t. Okay, now you have to find how long means time when velocity is 0. So I put v is equal to 0 is equal to, here it is minus 4 by 3t plus 16. Any doubt? Okay, now if you take 4 by 3t, this side is equal to 16. Is equal to 16. 4 into this 4. So if you take this 3 on opposite side, you will get t is equal to 12 seconds. You will get t is equal to 12 seconds. Clear? So you have to understand this language. Okay, how long means you have to find time when object comes to rest means velocity is 0. Now another question. X is equal to 80 square minus bt cube. At what time acceleration is 0? Acceleration, and you are given position. So first of all you have to find velocity z. V is equal to, differentiate this, 80 square means it is 280 minus bt cube means it is 3bt square. In differentiation, again if you have any problem, send me doubts on my WhatsApp number. It is velocity. How to find acceleration? A is equal to differentiation of velocity. 280, what is its differentiation? It is 2. 3bt square, what is its differentiation? It is 6bt. It is 6bt. Now you have to find at what time acceleration is 0. So put acceleration is equal to 0. 28 minus 6bt. So therefore 6bt is equal to 2a. 6bt is equal to 2a. So t is equal to 2a upon 6b. Therefore t is equal to a upon tt. So it is your answer. Okay. So now these questions are to clear your concept. These questions are to clear your concept. Some extra similar questions I will send you as worksheet and you have to solve worksheet. Yes, if you have any doubt, then we will discuss these doubts in Zoom meeting. Okay, pause your video and write down from board.